In this tutorial, I will show you how to plan a mandible reconstruction using Mimics Enlight CMF. We will start with just the CT images and go over all the steps needed to plan the case in 3D. The first step in 3D planning is making the 3D models that we are going to work with. And there are two options to do so. First, I will show you the manual segmentation integrated into the software. And then I will show you the automatic segmentation method by using the connection to our Mimics Flow platform. To import the images that we're going to work with, click on From Images, and then find the directory of the folder where the DICOM images are located. For this specific case, we're going to start from a scan of the skull and a scan of the lower leg. Once selected, the software will show a preview of the image series. Click on Open to continue with the selected images. I will first show you the steps for manual segmentation. Click on Reconstruction Planner and then Continue at the bottom of the page to start the planning. At the top, we can see the workflow navigation bar, and these are all the steps that we will take in the process. Although some steps in the workflow are optional, most steps will need to be finished before continuing to the next one. Here on the right, you can find the general toolbar regarding the view settings, measurements, as well as import and export options. The view will automatically change depending on the actions that we're taking during planning. And on the left-hand side, the actions are explained in the workflow page. In the preparation step, we can check the DICOM information by right-clicking on the image and then selecting Image Information. Now we need to make a 3D model of the skull, soft tissue, and the lower leg. But before we do that, we first need to indicate which scan belongs to which anatomy. Click on an image stack and indicate which anatomy it is. And then click on Next once you're done. Now we can go ahead and make our 3D models. Now let's start with the skull. After clicking on skull, we can see that the threshold already has been set to match that of bone tissue. Of course, we can still change the maximum and minimum if needed. And in fact, let's move the minimum gray value to 1200 to get rid of some blood vessels and floating voxels. Click on Apply to continue. We can use the Erase tool to get rid of the remaining unnecessary parts. We can just draw around the parts that we want to erase. And this works both in 2D and in 3D. For a proper planning, we need to separate the mandible from the rest of the skull. Use the tool to mark the skull on a few slices, and we will see our 2D input also appear in 3D. Be sure to mark around the temporomandibular joint and the teeth, because that's where the two models are closest to each other. Now do the same thing for the mandible. Once we're done with the marking, we can click on Split to separate the models from each other. And after the split, click on Finish to continue. And now we can do the same thing but for the soft tissue. After setting the threshold, we can again use the Erase tool to remove all the unwanted parts and then click on Finish once we're done. As I mentioned earlier, there's also a second way of creating your 3D models. Now I'm going to show you how you can request the automatic segmentation via the Mimics Flow platform. Just as before, you need to start by loading in your images, but only the skull images in this case. You can log into the Mimics Flow platform and start requesting the segmentation. First, you need to create a new case, enter a title, and then add all the additional details you would like to include. Once the case is created, you can select the algorithm you would like to use and submit the request. The case will then be uploaded to the cloud, and once completed, you can load in the final segmentation. And as you can see, the teeth and the root canals were also segmented automatically. So now that we have segmented our skull, we're going to segment the tibia, fibula, and the peroneal artery as well. Since an automatically segmented project does not include the scan of the lower leg, we will have to import that one first. After marking this set as the leg, we can start segmenting. We're going to lower the threshold just a bit so that the peroneal artery is much more solid. We don't want to lower the threshold too much because then we will start including soft tissue in our segmentation. After setting the threshold, we have the option to edit the segmentation if needed. And then after that, we have to indicate where the tibia, fibula, and vessels are. And this is done with the same tools as when we split the mandible and maxilla. There is also the possibility to choose a previously segmented STL file from your computer to import instead. Only the skull, mandible, and fibula parts are needed to go to the next step. And after finalizing the 3D model, we just have to indicate which leg we're working with. In this case, it's the patient's right leg. Here in this step, we have the option to manually trace the inferior alveolar nerves. I say option because this step is in fact optional, but for this specific workflow, I'm going to do it to show you what it looks like. To make the tracing easier, the images will be resliced so that the entirety of the nerve is located somewhat in the same plane. The panel here on the left-hand side tells us where to place the points in order to reslice the image. We only need to place one point on the mental foramen and one point on the mandibular foramen, and then the CT image is automatically resliced, as you can see here. Now we can start tracing the nerves by placing points on the CT image. While placing points, we can scroll through the images to make sure that the nerve canal is nicely visible. To stop tracing, either press Escape or double-click when placing the last point. Once this is done, we can move on to the next step, which is setting the natural head position. Setting the natural head position starts by indicating the Frankfurt horizontal plane. This is done by indicating a point in each ear canal and a point on the inferior border of each orbit. Setting the Frankfurt plane is actually just the starting point for the next adjustments. After clicking on Finish, we are prompted to the next screen where we can adjust the position of the skull in the 3 orthogonal views. We can drag and rotate every orthogonal plane in order to set the natural head position. The pink line in this view indicates the mid-sagittal plane, where the blue lines provide visual aid. The grid in the viewport can help us with that as well. Once we're done, we can click on Next, and that will bring us automatically to the osteotomy step. Now, before we do the osteotomies, I want to emphasize that the case we're about to plan is not necessarily clinically accurate. The goal of this tutorial video is to show you how the tools work. For actual planning, you should always consult with a trained healthcare professional first. Here, we will resect the part of the mandible on the side of the tumor. It is possible to visualize teeth and nerves while doing so. Click on Add Cuts to add our first cut. Indicate 2 points on the mandible and then press Create Plane. This will generate an osteotomy plane, which we can still modify by dragging the red control points around. When done with the first plane, we can make the second osteotomy plane next to the condyles in a similar way. Make sure that the orange side of the plane faces the area which needs to be resected. If that's not the case, invert the orientation of the plane with the corresponding button. And once the two planes are in place, we can click on Split to actually perform the osteotomy. The part of the mandible that will be removed will now be highlighted in orange. So now that we know how the tumor will be resected, we can start planning the reconstruction. Click Next to move to the reconstruction step. What we will do now is mirror the healthy side of the patient so that we have a reference. We're going to hide the rest of the skull because we don't need that during planning. Right-click the skull in the 3D view and hide it. After we've done that, let's hide the resected part of the mandible as well. Then click on Finish. The mandible will be reconstructed with segments of the fibula. To make these segments, click on Create Segments and start indicating a path from the healthy side of the mandible all the way to the condyle. The points correspond to where the segments will end. When we've placed our last point, we can press Escape to stop placing points. The fibula segments will be created automatically. The control points on the fibula can now be moved to match the healthy anatomy as close as possible. And if needed, you can also plan double barrel reconstruction. With the tools available in the panel on the left, we can make all sorts of adjustments like rotating one or more segments or sliding the segments around on the fibula. With the Adjust Segments tool, we can also change how the segments are placed against each other. On top of that, you also have the possibility to switch vascularization or to trim your segments. In the next step, you can add cylinders to simulate the position of your implants. Here you can also choose the diameter and the height, and after indicating the position of a new cylinder, you can easily adjust it further by moving the points of the cylinder. After completing all these steps, the planning phase is done. Now we can still export our parts to STLs, export the natural head position, or generate a report in PowerPoint format with detailed steps of the planning. And with that, we've reached the end of this tutorial.